All right, guys, hey, today we are going to start talking about graphs of sine and cosine functions. And so remember all those unit circle quizzes that we've been taking? This is where that is going to apply big time. So do you know what the sine of 0 is? Think about the unit circle, 0 degrees. What's the y value there? The y value happens to be 0. What about at pi over 2? Remember how sine is y over r, and the r is always 1 for the unit circle, and so the y value at pi over 2 is 1. 1 over 1 is 1. Just think about all the unit circle stuff that we've been doing for the past couple of chapters, and that is where I made this weird looking t-chart for the function y equals sine of x. Ever thought about what that graph looks like? Do you think it looks like a parabola? Do you think it looks like a line? What do you think? Well, now we can actually figure it out. And so what I'm going to do here is notice how all my y values are either 0, 1, or -1. And so that's why I'm going to label my y-axis as a 1 and a -1, and I'm going to put all of these x values. Obviously the x value here is 0, but it's like a weird looking sideways t-chart is what all of our graphs kind of look like. And this one here is pi over 2, that's my second x value. My first one is 0, my second one is pi over 2, and then pi, and then 3 pi over 2, and then 2 pi. I could have done other values like pi over 4 or something like that, but these are just the 4 quadrantal angles going all the way back to the beginning unit circle of 0 and 2 pi, same spot. And so those are the 5 different values that I'm going to be using when I graph these things. And so if I put a dot here at 0, 0, that's my first ordered pair right here, 0, 0. My next one is pi over 2, 1. That's going to be up here. And then I go back to pi, comma, 0. And then 3 pi over 2 -1 is going to be down here. Weird looking shape. Looks kind of like an S. And you know how we can keep going around and around and around the unit circle? It's really important to put arrows at the beginning and end of that S shape. And yes, it kind of does look like an S, and that is how I remember what the sine function looks like. Kind of like some parabolas put together, but it bounces between -1 and 1 forever, and that's going to help us figure out what our domain is. So because I put an arrow here, and because I know that the negative pi over 2, negative pi, that's going to give me the same y values here. It continues in this pattern to the right and to the left. Domain is -infinity to +infinity, or all reals. That's another way of saying that. The range, it bounces between -1 and 1. And yes, there are actual dots at 1 and -1, so I'm going to put a bracket around those. Let's remember back to Algebra 1, how you write domain and range. Everything in between -1 and 1 is what it bounces between forever. Let's go on to cosine. Let's see how that goes. So cosine, because that's the x value, obviously our t-chart's going to look a little bit different. But the cosine of 0, the x value there is 1. The cosine of pi over 2, the x value there is 0. Cosine of pi, the x there is -1, 0, and 1. Again, these are all just unit circle things. And so again, I'm going to label my pi over 2. This is 0, pi, 3 pi over 2, and 2 pi. Again, I'm bouncing just between 1 and -1, but the pattern looks just a little bit different. At 0, the x or the y value is 1. So I'm going to put a dot at 0, 1, which is right here. And then at pi over 2, my value is 0, -1, 0, and 1. Again, these are all the things that we've been quizzing you guys over for the past several weeks over the unit circle. This is where this is coming into play. Okay, again, domain, -infinity to +infinity, or all reals. I believe Math Excel asks you to just check the option all reals. I think that's how the Math Excel has it. And then the range is the exact same. It bounces between +1 and -1, and it just continues doing that forever. So again, bracket, -1, 1. Okay, so I'm going to zoom out so that you can kind of compare these two. Don't they have like almost the same exact shape? And actually, if you would continue it forever and just shift it around a little bit, it does look almost exactly the same. Here are the important things. The sine curve starts at 0 because the sine of 0 is 0. The cosine curve starts at 1, and the reason for that is because cosine of 0 is 1. What I want you to start thinking about is these y values are going to be really important as we graph harder graphs. These y values are going to be referred to as like the 5 key y values. And so for sine, the values are 0, 1, 0, -1, and 0. I just want you to kind of think about that and start gearing your mind towards memorizing and recognizing those as the sine y values. That's where I got those from. And then cosine is just a little bit different. Cosine starts at 1, 0, -1, 0, and 1. That's how we're going to be able to tell the difference. Again, those are the y values for sine and cosine. And the reason where I got those from, you don't have to have these memorized, you guys. You already have them memorized. You do not have to rememorize this stuff. These are from the unit circle. These are also from the unit circle. But just start paying attention to those as we do a little bit of harder examples. Okay, so we have this new vocab word that I want to introduce, and it's called amplitude. And the amplitude is defined as half the distance between the max and min values. So I'm going to look at this cosine graph here since I can kind of look at both screens at once. Copy that definition down and just keep in mind that since amplitude is a distance, the amplitude is always positive. Just keep that in mind, and I'll touch back on that in a second when we get to an example. But the amplitude for this cosine graph, so here's my maximum value. It's up here at y equals 1. Here's my minimum value, and you guys know what max and min means from Algebra 2. Maximum is the highest value on the entire graph. So even though this continues to the left forever and to the right forever, the absolute highest value is here at y equals 1. The absolute lowest value is -1. And the distance between that is 2 units. The amplitude is half the distance, so 1 unit. And the way that I like to think about or look at amplitude is if you draw this dotted line here in the middle of your graph, the amplitude here is the distance between that line and the top point. So this amplitude is 1. You could also look at it right here. The amplitude is 1 unit. The amplitude is 1 unit. It's the distance between the middle of the graph and the min or the max. 1 unit. And since it's a distance, it's positive. So what happens if I put this multiplier in front of the sine function? So here's the t-chart that we wrote at the very top of the first page. Remember, these are all of the x values on the quadrants, and these are all of the y values that go with sine. Remember that pattern, 0, 1, 0, -1, 0. What happens if I multiply all those y values by 2? They change to 2, and you can see my graph gets, I refer to it as more humpy. And I like to play the song in class, My Humps, okay? That just helps me remember what the amplitude does to my graph is that my normal sine graph that hasn't been multiplied by anything goes between -1 and 1 like we talked about. That's this red dotted line here. See, it says y equals sine x. But if you put a 2 in front of it, it makes it more humpy. And now my amplitude from this middle line all the way up to the top of the hump is 2. Remember, half the distance between minimum value and maximum value, that would be 2 here. And that is this number right there. And what you need to take away from this is that when you multiply a 2 in front of your function, it multiplies your y values. So all those zeros stay the same, but all the 1s and -1s change to 2 and -2. Now I've got another vocab word for you, and that is the last vocab word for the day, is this thing called period. And so basically what the period is it is how long does it take the graph, the curve, to go through your 5 dots. And so the dots that we did on the first page started at 0 and went up and then down and up. And that's referred to as 1 period, is what that looks like, okay? So 1 period is those 5 dots. There was 1 here, 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 and here. And so you guys know that if you put numbers into your formula, it changes it. It could flip it upside down. It could make it more humpy. What happens if you put a value in here with the x? So not in front of the function like this one, but what if I put a number in here with the x? What you learned in Algebra 2 was how to stretch and shrink graphs, and that's exactly what this 2/3 does. So this 2/3 is referred to as the b value, and so that is how you know that there is a period change, which all that means is that it takes longer or it could take shorter to get through your first 5 points. That means if you're in physics, and what sine and cosine graphs are really useful for is frequencies and wavelengths and sound waves and all kinds of stuff like that. And you guys know what waves look like. So if you picture the ocean, sometimes the waves are moving really, really slowly. And sometimes the waves are moving really, really quickly. And that is the difference between periods, okay? So this 2/3, I'm gonna plug into my formula right here, right for the B value, and that is gonna help me figure out my X values. And so what I do know is that what's going to happen is, instead of having 0, pi over 2, pi, 3 pi over 2, and 2 pi, those X values are going to be different on this graph because this number is not 1. Okay, so what I'm going to write here is I'm going to make a little bit of a note. This means that B equals 2/3. So I am going to use this formula right here, 2 pi over B, to figure out my new period. So 2 pi over 2/3 is the same as 2 pi times 3 over 2, so 3 pi. Okay, that means from start to finish, this number out here is 3 pi. Okay, so usually when we do one period of a sine or cosine graph, if the period is normal and there's just a 1 in front of the X value, then you go from 0 to 2 pi. In this case, my waves are moving a little bit slower. That's what the 2/3 does. So I'm going to go from 0 to 3 pi, and it's going to take 3 pi units of distance to get my 5 dots in. Okay, the second thing that you're going to do in order to figure out all these other tick marks, so here's one, here's another one, here's another one, here's another one, and here's my last one. How do I figure out how to label all the other ones? Well, my distance from here to here is 3 pi, and there happen to be 1, 2, 3, 4 gaps there. So I'm going to take 3 pi divided by 4 equals my tick mark length. So remember, the period was 3 pi, and that means from start to finish. But my tick mark length is 3 pi over 4. Okay, so again, a little bit of vocab being thrown at you. We're going to practice this big time in class tomorrow, but what does the period mean again? From start to finish, the 5 dots. That length is 3 pi. If this number is just 1 and there isn't a fraction there, then it's just between 0 and 2 pi, and your length is 2 pi for your period. In this case, I had a period change because of this 2/3. Here's what you do with that. You do 2 pi over whatever the B value is, and that gives you 3 pi. That's the period. How do you figure out what each tick mark length is? You do 3 pi over 4 because there are 4 gaps. Okay, so that means that if this is 0, when I add 3 pi over 4 to get my next tick mark, I'm just going to label that 3 pi over 4. Add 3 pi over 4 again, and that makes 6 pi over 4. Remember how to add fractions. Add 3 pi again, you get 9 pi over 4. Add 3 pi again, you get 12 pi over 4. And yeah, a lot of those reduce. This is the same thing. I don't care if you reduce them or not, but just notice that if it's like a multiple choice question or something, that this is probably going to be reduced. But you know how to reduce fractions. I'm not concerned that you do that when you're sketching your graphs. Okay, so there's my X values. So where do I put these stupid 5 dots? Do you remember the 5 key Y values for cosine? Look at the front page. Do you remember that cosine of 0 is 1? That's from the unit circle. And so for cosine, my Y values, I'm going to write down here, for cos are 1, 0, -1, 0, 1. And those Y values go on these 5 X values. So at 0, my Y value is 1. So I'm going to put a 1 there. Put a dot there at 1. At 3 pi over 4, I already have that labeled. My Y value is 0. That's my second dot. Do you see that it's making the shape of the cosine now? At 6 pi over 4, my Y value is -1. That's going to go down here. I'm going to label this -1. And then again 0. And then again 1. And now I'm writing over what I already wrote. Okay. Here's my cosine shape. Make sure you put arrows each direction. And again, just to refresh here, this 2/3 changed my period length, which is from start to finish. It changed it to 3 pi instead of the usual 2 pi. And my amplitude here, remember that word amplitude, the number in front, the multiplier of the very front thing, the sine or the cosine, that was just 1. That means the distance between my maximum and this middle point, or my minimum and this middle line here, is just 1. Okay, what I want you to do now is to see if you can just label the x-axis exactly the way that we did here, using the b value of 3 for this problem. So pause the video, see if you can manipulate this, what we did up here, to label your x-axis for this equation down here. The b is 3. Pause the video, see if you can get it set up. Okay, here's what it looks like, you guys. The b value here is 3. Yes, I'll deal with this -2. That changes my amplitude. That makes it humpy. And also this negative sign here is going to flip it upside down. But I'll get to all that in a second. Right now I'm just looking at this 3. This is the b. And remember, to find the period, you do 2 pi over b. That is the formula to figure out what the period is. And so when you plug in the 3 for the b, you get 2 pi over 3. What that means is from start to finish, the distance there is 2 pi over 3. Okay, and yeah, I have it labeled 4 pi over 6. Hello, same thing, 2 pi over 3. I just didn't reduce. You can reduce it if it bothers you. You do not have to. Okay, how did I figure out what all these tick marks are supposed to be labeled as? Each tick mark, you take your entire period from 0 to 2 pi over 3, and you have 4 different gaps there. So that's why I'm dividing it by 4. That gives you 2 pi over 12 when you flip and multiply this, which is pi over 6. That means starting at 0, I added pi over 6, add another pi over 6, add another pi over 6, add another pi over 6. So that's my x-axis, and that's the hard part of figuring out these graphs. The last thing that I need to do is figure out where to put my y values. So remember the y values for sine. You can look to the front page, but remember that the sine of 0 is 0, and then it goes 1, 0, -1, 0. Do you remember that this amplitude is 2 and it's also reflected? I'm going to make a little bit of a note about that. The amplitude is 2 and it's reflected because it's negative. Another way of saying reflected is flipped upside down. And so that means it's my sine S curve that's humpy by a factor of 2, and it's also upside down. But I don't really want to have to think about all of that, so what I'm going to do is I'm going to take that -2 value, and I am going to multiply all my y values by it. And that's going to give me 0, -2, 0, 2, 0. And so my very first value here at 0, the y value is 0. I'm going to put a dot there. Next one, at pi over 6, my y value is -2. So I'm going down 2. And then it's back to 0. And at 3 pi over 6, my y value is +2. Way up here, and then here. And look at it, looks like the S curve. It's upside down, and it's a little bit humpy. Okay, so remember things like amplitude, the distance between the middle and the maximum is 2 units. Same thing here, middle and minimum is 2 units. That's the amplitude. The fact that it's upside down is because of this negative sign here. And the period, 2 pi over 3, that means from here to here, the distance is 2 pi over 3. Okay, I know that was a lot, you guys. We are going to do a ton of practice in class tomorrow, but at least you got a bunch of really good notes. You have an idea of what we're going to be talking about in class tomorrow, and we'll answer a bunch of questions, practice, and get a lot more comfortable with this, okay? Sorry for the longer video. Hope you guys have a great night. I'll see you tomorrow.